Hello, everyone, and welcome to the Conscious Health Podcast. Today we have such an interesting guest, Dr. Mark Bartlett. And today we're talking about the tiny keys to better health, unlocking nature's peptides. So I'm going to do a very quick introduction here, and then we'll jump into a little bit more detail. So Dr. Mark Bartlett, a career rooted in nature's wisdom. He is a biochemist and immunologist who transitioned from a career research at NIH to pioneering advancements in natural health. So fascinated by nature's ability to support health proactively, he shifted his focus to plant-derived molecules and nutritional science. And for 30 years, he has explored how bioactive compounds and peptides optimize human health. Now, as Chief Scientific Officer at Make Wells, Dr. Bartlett leads the development of bioactive precision peptides, a revolutionary approach to natural health and longevity. His career spanning immunology, biochemistry, genetics, nutrition, and dedicated to harnessing nature's wisdom for the healthier, longer lives. Oh my goodness, I am so excited to talk to you. Tell us a little bit about your journey.
I have an accent a little bit like yours, Natasha. I'm from Australia, a different Commonwealth, right, from South Africa.
Yes.
I've always, Australia is just a weird place to grow up. Like, we've got like the most poisonous snakes and spiders. Our trees are all, mostly eucalyptus. We've got these mammals. We've got mammals that lay eggs. Like, it's just a weird place. And if you have any inkling at all towards science and natural science, then it's a place to be. And so ever since I was a kid, I've been fascinated by that. So born in the country, and really nobody in my family had been to college. My grandmother couldn't even read and write, but I was determined to learn more science. And so I just kept learning more science. And so, studied photosynthesis and how plants really capture carbon dioxide from the air and photons from the sun and actually create all of the molecules of life. So soon after that, I thought, well, wait a minute. How do these interact with the human body? How are they bioactive? So that led me actually to study immunology with a focus on cancer research and cancer immunology. And so that led me then to study in the United States, postdoctoral research here. And at that point, it dawned on me, I guess it was kind of obvious when you think about it, that most of the drugs, at least in those days, were inspired by the plant molecules, but modified by science, maybe made synthetic, things added to make them more potent. A good example is the salicylic acid that comes from the willow bark, right, which had been known for centuries to be good for sort of those, inflammatory diseases. And then the Germans were brilliant. They're like, well, how do we make this more potent? How do we make it last longer in the body? And the simple addition of a acetal component, right, extended its life and its potency. So now we have acetyl salicylic acid, which is aspirin. And so at that point, I thought, well, there are so many phytochemicals that nature has to offer that are bioactive. We were just starting to learn, 30 years ago, a little bit more about like the carotenoids and what they do, the polyphenols and what they do. They're all bioactive, and you get them in the colorful plants. So if you modify those to cure cancer or autoimmune disease or whatever it might be, what if humans, odd idea I know, partook of colorful vegetables all of their life so that there was a modifying effect that kept you healthy? And so at that point, I left the National Cancer Institute and started to dig into this sort of plant bioactives. And that led to where I am now with peptides, which are really an interesting facet of this bioactivity.
Can you describe what is a peptide for all of us?
Yeah, sure. So,
the same. So.
yeah, so in the context of bioactives from plants, you've got all sorts of things that interact with the body, right? Some are feeding the microbiome in the GI and therefore affecting overall systemic health. Some might be antioxidants that you get from the fruits and vegetables. Some might be triggering a better immune response. Some might be triggering a better detoxification response. So nature is full of all of this. But ultimately, it filters down to the cell and the cell-cell communication. And the way that cells communicate is through small molecules called peptides. They're basically amino acids that have been strung together in a particular sequence. So I think, that's what the DNA does, right? The DNA in every cell is really just a blueprint for how to put together these amino acids in a particular order. And in the sense of a protein, it will fold a certain way, right? Because each amino acid, maybe I can demonstrate a little bit. So let's say that these are all amino acids, right? Each color is a different amino acid. So each amino acid has a certain quality. It can be positively charged. Maybe this one is negatively charged. Some of them might be hydrophobic, meaning they hate water. And some of them might be hydrophilic, meaning they love water. And so when you put them all together, when the DNA codes them, then they want to fold a particular way. And that gives them a three-dimensional structure, not to mention sort of charges that enable it to bind to, basically, if this is a key, then there's a lock. And there are thousands of them in the body and thousands of possibilities, all encoded by the blueprint. So a peptide is really just, if a protein is a really big structure, a peptide is just a really short structure, just a couple of amino acids long to maybe 50, maybe maximum 100. That's what a peptide is. And that peptide is allowing the cells to communicate with each other. So for example, if you use your muscle, if you're doing sort of a weight-bearing exercise, the muscle says, well, this means that the rest of my body has to get into gear. So it sends out little peptides. Like there are 600 of them that come from the muscle alone that message the rest of the body. And I'll just give you an example of one of them. It's called brain-derived neurotropic factor, BDNF. So it goes to the brain. And it actually helps with neuroplasticity and memory. So, use your muscle, build your brain. And there's another peptide that might go to the bone and say, build mineral density, because you're going to need it because you're doing something hard. So that's an example of what a peptide is. We can talk later, if you like, about now what medicine is doing about that and how they're tapping into that power.
So does that mean that peptides act like molecular kind of like messages, like
Yes.
activating kind of like the dormant DNA codes or whatever it might be, whatever it is that is there? I'm interested in it from a kind of like a blueprint perspective, because I work more on kind of like the spiritual side and looking at the blueprints of kind of like intergenerational kind of like your ancestors, as well as kind of like your environment, the lands that you're born in, things like that. So is it right to say that they would probably be kind of like hold the construct of your being, but we're not, I also don't believe we'd tie to it just because our fathers, ancestors suffered with cancer does not, what might mean that we might have a certain environment for it, but we can change that physically, mentally, emotionally, and spiritually. Is that
Yes.
is that right? Have I got it right?
Yes. It's so interesting because the sense that you have about the importance of DNA, even up until recently, not everything was explainable, right? So you had this notion of like, wait a minute, like it feels like I have more than just the blue eyes from my father or the height from my mother. It's more than that. There seems to be like a memory in the DNA that goes kind of beyond my physical structure. And that sense has been explained, at least to a certain degree, in a new field called epigenetics, meaning above the gene. So the gene itself has the code. and it is fixed and it does not change. It's there for life from the time that you were conceived, and the mother and the father's genes sort of made this beautiful combination. That's fixed. It does not change. And, it's just, aside from that, you also pick up sort of not just the traits, but maybe some of the faults in the DNA. For example, there are about, I don't know, at least 1 million what they call single nucleotide polymorphisms, which mean that sort of one of the pieces of this DNA that maybe codes for something like a protein like this, each of those 3 codons there, those 3 base pairs that make a codon, will code for a certain amino acid. And if there's a mistake in that, if you have a G instead of an A, or a C instead of a G, GATC, that's basically the 4-letter codes, then you have maybe a problem or maybe not. Maybe it still codes for the same amino acid, so no big deal. Maybe it codes for a different amino acid, but it doesn't affect the folding of the peptide or the protein, then you have no problem. But if it's an amino acid that is a substitution that sort of changes the shape, now you have sort of a genetic disease that may be a real problem, like the enzyme may not be as effective, right? So that's kind of the basics of the DNA. The average person has about 30,000 of these like imperfections, right? From Adam and Eve to us, we've accumulated that. For the most part, it makes no difference. It just kind of makes us a little bit unique. But that is the fixed code. Then sort of what you're talking about, there's an epigenetics, which means that on the DNA, or the message that's encoded from the DNA, now kind of much like the chemists added an acetyl group to salicylic acid, the body can actually add things on top of the DNA that affect how it reacts. So the DNA is a beautiful thing. It doesn't just sort of, it's not just like a metronome that says, okay, produce this protein and produce that protein. It actually helps the body to maintain what we call homeostasis, right? So let's say you are hot. Your body knows how to cool down. It's going to, if it's really hot, it's going to actually produce a protein called a heat shock protein to help sort of the proteins to survive the extra heat. That's actually due to a dimmer switch on a certain gene. And so the DNA will open up its structure, the machinery will come in, and it will start to produce the heat shock protein. Or if you're stressed, it'll produce another thing. Maybe the adrenal glands will produce more cortisol. Or if you are, upset or stressed. And now let's take this to the mom who is pregnant. They've done experiments with mice, right, and rats, and they show that if the mother is extremely stressed, living maybe in an alley in New York City, and there are alley cats around, and food is scarce, so the mother is like nervous, and she's finding her food, but she's pregnant. Well, what happens is the DNA hasn't changed and isn't going to change, but you get these methyl groups and acetyl groups that sort of add themselves to the gene that then slow down the production of certain things or upregulate the production of certain things. So those mice that are born to that stressed mother will be kind of stressy. They will be shy. They'll be nervous. Whereas if you've got like a fat and happy field mouse where food is plentiful and no predators, and she's pregnant, her offspring, even if they have identical DNA, her offspring will be more relaxed. They'll take more risks. So that's epigenetics, and it works for us, for humans as well. So we know that if the mother or even the father smoked, that's going to actually affect the epigenetics of the offspring for a couple of generations, and so on. So your behavior, how stressed you are during pregnancy, all those things, it's really quite fascinating. But back to the topic of peptides, again, it's a homeostatic mechanism. So these are communication molecules that help the body to adapt. And some of them are very immediate, like all of the hunger signals, most of those coming from peptides. Here's where we sort of move into an evolutionary biology mindset. Like if the body, I mean, when you think about us, Natasha, David, maybe human beings 1,000 years ago. Like, imagine what that was like. Like right now, if I'm hungry, I can go buy, you know, I can buy Mexican food right on the corner here. I can just, find food anywhere. It's plentiful. I'm not stressed about it. I can just go get it. Well, what was it like 1,000 years ago? Like you're probably farming for your food. Maybe you were hunting for your food. And so you're expending a lot of energy and you're always hungry because your body was actually designed perfectly from a genetic standpoint to be living and surviving in times of scarcity. That's why we were designed, right? We don't immediately collapse if we don't eat for 3 days. Like our body can handle that. Heat, cold, stress, all these things, our body can handle it. But when you think about how our bodies were designed, we have a very keen sense of appetite, like food seeking behavior is what the scientists call it, right? That is driven by peptides. Right? There are peptides that are hunger hormones, ghrelin, leptin, glucagon-like peptide. These are all the messengers that go to your brain and say, find food, find food. And so we have it very well. I think you're like this. Like we're all like this. I can eat a big dinner and then I'll come home and I'll open the fridge and like, I wonder what's in here. I'm like, how is that? Why is it? I just ate. Why is my brain still telling me to look for food? There's another sense to that too. Like, muscle looks good on you, right? It looks good on everyone. You want to be sort of fit and healthy. But those peptides that I told you that muscle produce when it's under stress, if it's not under stress, and if I'm sitting at my computer all day not working for my food, then another peptide is produced called myostatin. And that just means muscle steadying or muscle, in this sense, muscle reducing. Right. The myostatin is produced so that the muscle declines because it's energetically expensive to keep it. So if you think about all of these messages and coming from the DNA and homeostasis, it's all about our perfect design for scarcity. That's where you might sort of, because our evolution has not caught up with our modern lifestyle that is sedentary with plentiful food. Now we're seeing this explosion of metabolic disease in the world, right? People are overweight, which is affecting their whole metabolism. They are becoming diabetic. We're seeing all sorts of things in the last 50 to 100 years that we've never seen before. And this is where we can look at peptides and go, maybe there's a way to sort of just soften that evolutionary signal, calm down the hunger signals, calm down the immediate response of the body to try to shed the muscle, which is part of your healthy metabolism.
That's what I was going to try to summarize and also ask if I'm correct in this idea. You explain us now this epigenetic model that I think that many people are now looking at, because this is the answer to the destination or the destiny that genetics gave many people. And they said, well, you have this gene, so you're going to die because you have a gene of cancer or whatever it is. But now you are telling us that these peptides and many of the molecules, endocrine molecules and immune molecules inside of us, they respond to the message of the environment that we create. So we have sort of power to create a new behavior, and by creating a new behavior, we start sending different signals. So we start allowing our own bodies to repair, to build new peptides, to build, of course, this amazing molecule BDNF that is repairing and creating neurons.
Yes.
So how can people start sensing more their own bodies in terms of not letting them just be triggered by external signals, such as the one that you describe in the hunger signals, for example, no?
Yes. You hit on a very good point here. This is, again, 30 years ago when I sort of left the cancer research and started to move into natural products and natural health, it was very clear as part of that a lot of the disease that we face today is a lifestyle choice. It's a lifestyle thing, right? So whether or not you choose to smoke or drink too much, or whether or not you choose to eat food that is high in caloric density and low in nutrient density, whether or not you choose a salad that's full of color instead of sort of just the brown and white foods, right? And whether or not you choose to be physically active. And now, a really nice realization that it's also the mind. So there's mindfulness, there is the present, there is meditation. All of these things have physical effects on the body, like dramatic physical effects. The idea of there are some major areas that are kind of maybe a little bit more difficult, right? So if I'm eating too much, then people will say, well, it's all in your mind. And yet there are so many other things that are related to it, right? Stress and experience and trauma that you might be dealing with and boredom or, a million things. And so then that goes back to this mindfulness, whether it's yoga or meditation. There's a lot more to it than just a fad, right? It's not just me and my yoga mat and my lycra. There's a reason for it, and it's to help this. You can't ever look at things one-dimensionally. Sometimes it requires coaching, right? And I don't know a whole lot about you, Dave, but your title there says holistic coach. And that sounds perfect, right? Because then you see the big picture and you help people. And if someone has an issue that they're dealing with or struggling with, you say, well, it's not just a drug. It's not just, use your self-control. It's like, let us help you. Let us put all of these things together and help your body to work the way that it was designed.
Yeah, I think that's what is amazing about science, that we are also understanding now that it is not just a straightforward road, and it is not just black or white. There are multiple dimensions, as you tell us, and as we have seen now, the effects of meditation, the effects of breathing, the effects of just having some minutes to regulate yourself, to be in silence, to detach from these triggering signals.
Yes.
That changes the environment, the chemical environment inside of you, and that allows the production of different forms of peptides.
Right. And, we're living, David, you and Natasha have probably seen that, at least in America or in the Western world, I'm from Australia, it seems to be similar there, that science is great and medicine is great. We've uncovered so many things, and I feel very blessed to live in this day and age where we have life-saving surgery, antibiotics, like all sorts of things where people died once and now you can sort of recover and it's almost routine. But there's also a temptation for us to just want to press the easy button. So if I have a disease or a condition, there's a drug for that. And while some of these drugs may be life-saving, maybe there are natural alternatives that we should consider, right, from a holistic perspective. And the same is true with peptides. So the reason why, probably David and Natasha, probably the reason why you're interested in peptides, like most people, is because in the last few years, there has been this revolution in understanding, like, wait, what's this Ozempic stuff? It's like, I don't even recognize that movie star anymore. They were kind of chubby and known for their chubbiness, and now they're like skinny, and I don't even recognize them. So this is peptides, right? People have understood what's Ozempic, what's Manjura. Oh, they're peptides. We've known that insulin is a peptide. It's been around for 100 years, saving lives, right? But so it does show you the power and the potency. But once again, like, while these have their purpose as synthetic drugs, can I spend a minute or two explaining to you the difference between that and what the approach that I think is maybe an alternative?
Please.
Okay, so let's look at the at hunger and satiety. So, again, our brains and our genetics, our evolutionary biology sort of drives us to seek for food. And generally, that food-seeking behavior also was accompanied by a lot of physical exertion, either farming or hunting. Now it isn't, right? So you still have that hunger. When you finally get food, so you're eating a meal. There are macronutrients, right? Carbohydrate, fat, protein. There are cells that line the GI called L cells, and some of them are called K cells. They sense the nutrient, they sense the macronutrient, and they say, oh, this fellow's eating. So probably should send a signal to the brain to tell the brain that food-seeking behavior can now be put on the back shelf. Like, you don't need it now. Stop hunting for food because you're eating. And maybe send some signals to the brain that you are getting full. How does it do that? Well, those L cells produce a molecule called GLP-1, right? And that GLP-1, a glucagon-like peptide, it's a peptide. It goes to the brain and says, don't worry about looking for food. It also goes to the pancreas and says, hey, maybe a little more insulin would be nice because you're gonna see some sugar and stuff in the blood soon. So it's an amazing orchestration of what happens to help you feel full. Other signals from GLP-1 say to the stomach and the gut, hey, slow down slow down a little bit because you're going to be digesting the food as well. So now, scientists discovered this and they said, wow, like if we inject this GLP-1, we're going to have a major effect on appetite. We're going to be able to help people to stop eating if they've got struggles or if they're pre-diabetic or type 2 diabetes. This is just what they need. Let's create this GLP-1. But the first thing that you notice when you synthesize, one of the first things you notice about peptides is if you try to eat them, then there are proteases and peptidases that break them down so that they are no longer a special shape that will work, right? Now, there are peptides in nature that do survive the GI. We can talk about that in a minute. But for now, scientists who were able to make the GLP-1, it doesn't survive GI, so you have to inject it. And even when you inject it, the blood is also full of these peptidases. I sort of describe them like sharks, right? So this guy is DPP4. This is the guy that breaks down the GLP-1. And if you inject it, it's going to break down really fast, too fast to do anything, right? So how fast does it break down? Like when your body produces that peptide, it's a concept called a half-life. I'm not sure if you're familiar with that, but in a half-life, half of it will be gone within that time, right? So GLP-1 has about a 2-minute half-life. So the L cell produces it, and it's only got 2 minutes to get to the brain, 2 minutes to get to the pancreas, 2 minutes to get to the gut, and it's gone. So while you're eating and while that receptor is occupied, the DNA is encoding for production of more and more while you're eating. But it's broken down really fast. So let's call it Snapchat, right? It's not a permanent text. It's just like it disappears almost as soon as it's made. And so how did scientists get around this when they were trying to synthesize GLP-1? What they did was they found, well, this shark is a dipeptyl peptidase, and so it likes to eat the second one in. Maybe we can do an amino acid substitution there, and maybe it won't be subject to the breakdown. So they bioengineer it so that it's not exactly the same, but enough to give it the signal, but to resist the breakdown. So now you've got a peptide that lasts a long time. And have a guess, you guys, the synthetic GLP-1, how long is the half-life? A quick reminder, the natural GLP-1 has a half-life of 2 minutes, meaning half of it's gone within 2 minutes, 3/4 of it's gone in 4 minutes. So now the synthetic, you want to guess how long it lasts before it's broken down, what the half-life is?
Let's say 4 hours.
Try 7 days.
Oh.
That's too much.
Right. So now, you have a peptide that is very effective. That's why it's so effective, because it's resisting degradation and it is constantly sort of telling the brain to stop eating, constantly telling the gut to slow down its transition of food, constantly and like you think about now from a holistic perspective, You guys probably know that the gut is responsible for about 95% of your happy hormones, right? So, like when you shut down the gut, then you risk major impact on mood. When you shut down sort of eating, then you also have a major effect on the maintenance of muscle. And so all of these things, they're not just disrupting your metabolism, but they are affecting mood and all sorts of things. So when you have something that has a long half-life like that, then you need medical supervision. It has its place, but it also comes with a big caution. And that sort of leads to where I am right now. We can actually find peptides in nature that survive the GI, that also have a reasonable half-life. They're broken down, so they assist the body, they coax the body, and they can be, and they're probably safer than any drug because they're broken down so quickly into amino acids. So they don't have to go through liver detoxification pathways or anything like that. And you find them in nature, like mother's milk, especially colostrum, is absolutely chock full of peptides. These are bioactive peptides that survive the GI. Defensins that are sort of immune, antimicrobial, antiviral, lactoferrin, which is really good for the immune system. There's others that help us sleep. So, right from the time we're born, we are actually responding to oral peptides. There are also peptides in the food that we eat, but sometimes it's a little hard to find them and a little hard to pull them out. And so we now can use the power of AI to go through the genetic code and say, look, this is the peptide that we want. This is the peptide, for example, that helps with muscle maintenance. Can we find that exact sequence in nature? And Natasha, if I said to you, here's the genetic code for the fava bean, like go find that exact word. And to give you an idea of the task that you're facing, the human genetic code has 3 billion of these base pairs, 3 billion. And if 3 base pairs make a codon, which code for an amino acid, that means there are basically 1 billion words in the genetic code of the human, in every cell. And that's equivalent to about 900 big fat encyclopedias. So it would take you a long time to kind of try to match that up, but AI can do that in minutes. So now we are living in this age where we can use AI to find the peptide, and then it's a matter of sort of teasing it out and testing it in cell culture models and in humans to see if it's working. So that's the space now that I think will very soon revolutionize the health industry because it's safe and it's coaxing the body. It's not sort of synthetic with a long half-life. Great possibilities there.
Yeah.
I love that. That's so interesting. And I love that you look at the body, like in kind of like bringing in balance to the body rather than looking at treating the disease in itself as well, which is quite beautiful. And that is very, very fascinating. And also, I believe that we live in this world where nutrition isn't the same as it was 30, 40, 50, 100 years ago either. That coupled with a lot of kind of like the chemical kind of like intake that we do. I mean, I have a teenage girl who's kind of like bronzes and nails and face, and it's just like a flood of chemicals running through our bodies. And it's incredible that you can very quickly see what is lacking and create it in a way, but and absolutely in a way that kind of like supports, supporting that treatment by, looking at physically, mentally, emotionally, doing the exercise, doing the mindfulness and all the rest of that. It's absolutely fascinating that we can work with technology to really figure out who we are. And I think that we're coming full circle in the sense of looking at things more naturally, looking at kind of like how do we live more holistically?
Yes, I think there are certain things that have happened, Natasha, that have really helped people to sort of, I don't know, just highlight their view, just along the lines that you were talking. Think of this, now we're understanding microplastics, right? And we're understanding toxins in the environment. I remember I was doing a project with the in vitro fertilization program in Australia. They're kind of pioneers in that area. And they were, the topic was male infertility, and I was in a team that was looking at fatty acid oxidation, lipid peroxidation in the body. So this was a branch of sort of the antioxidant sort of line of science. And so my task was actually to look at human semen. And, if you oxidize, if you sort of have lipid peroxidation there, you can affect the sperm motility. It's a weird sort of a subject, but I was looking at sort of lipid peroxidation, and there are certain markers. And so I partnered with a guy at the CSIRO in Australia, the Commonwealth Research Industrial Organization there. It's like the NIH here. And he had this massive mass spectrometer that was extremely sensitive. And so we put samples into that spectrometer. And usually you have these little fine peaks that come out, right? And you say, okay, this is the peak you're looking for. This is the lipid peroxide. And, that may be affecting sperm motility and fertility. So, but what we saw was like this huge mountain of a peak before that was almost obscuring the peak that we're looking at. And I said to the this PhD expert in mass spec, well, what is this peak? Have you looked at this, like this big interference? And he says, oh yeah, that's phthalates, which are plasticizers, right? Softeners. And so this was 40 years ago in Australia, a relatively unpolluted country. And yet in the semen of the average male at that time, you already had evidence of a massive influx of sort of plasticizers. And so think of it now. So this, people have become aware that there are metabolic disruptors, right? It can be air pollution, it can be the food that we're eating, it can be the pesticides, all of those things that sort of accompany our diet and our breathing and even drinking water. And we start to realize that there's holistic then moves into this other area of clean label and transparency. If you've got products that you're creating, then use as few synthetic or sort of metabolic disrupting kind of excipients as you can.
I was thinking about the comparison that you did of the GLP-1 that is synthetic, the one that they are injecting, and this huge half-life of 7 days. What happens? You described that it affects our brain. Well, the signals of the brain to perceive that you are full, or to give the signal that you are full.
Yes.
And also the signals to the muscle. So let's say that a person that wants to lose weight wants to consume this product because, of course, of the advertisement and all of those things. What happens if you are unsupervised and you use it without precaution? What happens in the brain and what happens in the muscle?
Yeah, I think right now, well, when we started, like, there's always a miracle drug, right? And you just go, wow, this is too good to be true. It usually is. It has dramatic effects, but sort of often we think of the now and we don't think of the future, right? And so it's like Marty McFly in Back to the Future, right? Marty, you're never considering the future, are you? So this is kind of like how humans are. It's like the easy button, right? So we're starting to see now that quite a percentage of people on some of these very potent peptides are coming off them due to side effects, right? They just immediately don't feel good. They immediately maybe feel sick. In some ways, maybe they're the lucky ones because they're not then on this long-term journey where the side effects may be more dramatic over time. Like you may be losing muscle mass. And then you think, well, maybe it's time to go off this. And so you go off it and your appetite comes roaring back and you eat a bunch of food and now it's coming back as adipose tissue and you've already lost your muscle. And adipose tissue is metabolically active. It's pumping out, steroid hormones like sex hormones. It's pumping out inflammatory markers and cytokines like interleukin-6. So it's affecting and increasing systemic inflammation in the body. And at the same time, you've lost your muscle. which is sending all those other signals to the body and is part of a healthy metabolism. So I'm talking theory here, but we've already seen this in practice, right? Muscle mass loss, depression, some of these other things. So there are some warning flags right now, but it's big money. And, I don't want to get too much into politics. If you're interested in that, there are podcasts with Casey Means and Callie Means, her brother, and it's just so interesting how interconnected this all is. But, big money usually sort of sometimes drives the narrative. And we have to be a little bit, we have to be cautious about that. We have to sort of look after ourselves. We have to write our own prescriptions and not believe everything that you're told, study it out and maybe find a holistic coach that has educated himself in this a little bit.
Yeah, well, the question was exactly for that, because many people nowadays take the easy road and they just take these popular remedies, let's say, these drugs, and they don't think about the future, and
Yes.
they just consume it while they are destroying their own bodies and their own signals. So now it goes the next question. The peptides that are natural and that you can build with these simple instructions, but being aware that you don't want to create a powerful miracle molecule, how long do you make them if they are from nature, and what are the effects, the healthy effects of the peptide?
Yeah, let me, I can give you a couple of examples. So let's look at muscle. I just love, you can tell I'm a little bit passionate about that because the muscle is now considered an endocrine organ because there's so many messages that come from the muscle that affect your entire metabolism. So there are researchers in this area like, Wolf and others who have for years been saying that your muscle is your youth. And your muscle is healthy metabolism. And you want to avoid this condition that they call sarcopenia, which is muscle loss. And it's often associated with age, right? And so now if you look at how the body, I've already talked to you about the evolutionary biology. Like even a young person, if they don't use the muscle, then they will lose the muscle. And it's part of the evolutionary program that, well, it's taking up too many calories and you don't want to burn too many calories, do you? Without realizing that, no, we live in this modern age where we can get calories wherever we want and we're sedentary. So now you look at the muscle and there are lots of receptors on the muscle. So you've got probably the most well-known is the androgen receptor, right? It's a nuclear receptor. And when it's bound by, say, testosterone or an anabolic steroid is the synthetic equivalent, right? It will tell the DNA, message to the DNA, hey, build protein, build muscle protein, grow. And that's kind of how it works. It's kind of why men often have bigger muscles than women, although women can also use testosterone to activate the same receptor naturally. Then you've got, so there's that, the androgen receptor, but there are also other more hormone receptors. And those hormones are peptides often, right? So you've got one called the insulin-like growth factor receptor. You've got another growth hormone receptor. There's a vitamin D receptor. There are also receptors for mechanotransduction, right? So that means when you're squishing the cell, when you're using the cell, that's called mechanotransduction, and that's almost the same as being occupied by, a hormone receptor being occupied. So again, holistically, if you want to keep your muscle, you should be using the muscle. You need to have the micronutrients that you need, like vitamin D. There's another receptor called, it's basically a nutrient sensing receptor. So if there are sufficient amino acids in the blood caused by eating protein, that will also trigger that receptor. And all of these things work together. Sleep is super important because most of the hormones, the growth hormone for the muscle for recovery and growth, happens during slow wave or the deepest part of sleep. So it's all interconnected. You can't just say, well, take this drug and grow your muscle. There's a whole bunch of things going on. So on the peptide side, you have to realize, okay, so we have found, we're working with a a really good biotech company in Ireland who discovered using AI that the fava bean has a peptide in it that will bind to that to one of the growth hormone receptors on the muscle. And that's terrific because that's a way of just sort of sending a natural message to the body, like stay around a little bit longer. Like, I love you, please stay. You don't have to go away so fast, right? And it's a gentle message with a short half-life, but as you age, that nutrient receptor that's sensitive to leucine and glutamine, the amino acids when you're eating protein, it kind of fades a little bit. I have found as I get older, I'm in my 60s now, it's kind of harder to keep the muscle on. And so this natural peptide is a great strategy. And for me, it's helped like, oh, I can feel the muscle is staying now, for the same amount of work, because I'm still working out, the muscle is staying longer and looking healthier. So that's one approach. That's, again, a natural approach. It's found in nature. Interestingly, if you just eat fava beans, you can't, it doesn't sort of uncloak that peptide. And so doesn't matter how much fava beans you eat, you won't actually see that effect, except maybe from protein triggering the nutrient receptor. But if you, with the judicious use of certain proteases and peptidases and the right heat and temperature and pH, you can get that fava bean biomass and tease out and filter and find the peptide that is activating that receptor and promoting muscle maintenance. And so that you can test. You can test it in cell culture models where, all sorts of wonderful fluorescent techniques now where you can sort of, in a cell layer of the kinds of cells that you're looking at, like a muscle cell, you add that peptide and you have like these indicators that show, where it's working and whether it's working. You also need to test and make sure that it survives the GI. So you use a simulated gastric solution. And then when all of those things work and you found the peptide that seems to be working really nicely and binding to the right receptor as predicted by the AI model, then you test it in humans and see how that works. And that's the ultimate test, right? The human clinical study where you see maintenance of muscle compared to a placebo.
Dr. Bartlett, where do we go to find out what it is that we're needing? How does it work? Like, I mean, you mentioned hormones. I live in a house where I have 2 teenage girls and I'm going through perimenopause. There's a lot of hormones happening here. Mm-hmm. So yes. Where does one start this journey in finding out what it is that we're needing, what we're missing? What do we need to replace? How do we bring in that?
Yeah. So, the three of us, I'm sure, are very passionate about this, right? And it's a lifelong journey. Like, I finished my undergraduate 40 years ago, and then I finished my master's 35 years ago, and I finished my PhD 30 years ago, and it's been lifelong ever since, right? So you never sort of come to this point where you stop learning, and also science is uncovering more. But I don't expect the average person on the street to sort of have the time and the passion that I do, that you do, David and Natasha, to look for all of these things. So it's such a good question, and I don't know if I know the answer. I mean, this is why we're on this podcast, right? We're trying to get this information out there in an easily digestible format. Hopefully it has been, making people aware that there are alternatives. But then, you don't want to be sort of a Google scientist either, where you're sort of getting pseudoscience. So you do need to find science that you trust, people that you trust, coaches that you trust, and ask the curly questions. And I'm not afraid to admit I don't know the answer to all those questions, but I think that we're going to see more and more. Like, I do a podcast, it's behind a firewall, but every Thursday, we have a bunch of people that are listening and learning about the power of peptides and the difference between the real peptides from nature and, what the pros and cons are. It's a lifelong journey. I would just say knowledge and learning is a marathon, not a sprint. No. And in the same way, any natural alternatives to drugs is also a marathon, not a sprint. Like the peptides that we're using from nature, they're a marathon, not a sprint. So I think as soon as you expect miracle cures, maybe then you need to rethink things.
Yeah.
And maybe Natasha and David, maybe you can answer that better than I can. Like, where do you go for this kind of knowledge and information about what you need?
I was wondering if you kind of like look at, say, for example, somebody that's like a naturopathic doctor that specializes in something or other. You know, just looking at it from that perspective as well. I mean, the
I
mental, emotional, yes, a coach. You know, like
yes.
start looking at food and all the rest of that. But yeah, it'll be quite interesting to see. Yeah.
Yeah, let's look at your example, Natasha. I mean, that was beautiful advice. Like, okay, my wife is going through, or she's just past menopause, right? 50 years old. And she noticed things that were going on, like brain fogginess,
Hmm.
hair falling out, like certain sort of things that happen when there's a bit of a hormone disruption going on. Nature is kind of cruel. Nature kind of says, like, when you're past childbearing age, I really don't care how you look anymore. Like your skin, the degradative proteins are going to start breaking down the collagen and elastin. There are peptides for that, right? There are peptides that trigger the damage receptors in the fibroblast that help then to overcome nature's loss of interest in the female beauty when she's past menopause, right? So there are, and when it comes to the hormones, the loss of hair, things like that. My wife went to her doctor, and he says, "Well, we've just done a panel, and everything's kind of within normal parameters." And she's like, "Well, then why am I losing my hair?" Well, we don't know. It's just a part of life. So at that point, then you just say, "Well, I'm going to get a second opinion," and that's when it sort of starts to be a little bit more out of pocket because it's now out of mainstream. My wife found this wonderful female hormone doctor. She does a full panel and she says, well, it's obviously this, and this. And here's what we're going to do. We're going to put you on a bioidentical sort of hormone replacement, and we're going to do this and that. And, you know, and now she feels wonderful. Her hair's not falling out. She looks beautiful. She's like not stressing from these mood swings and hot flashes. It didn't come from mainstream medicine. I think that there's a transition that's happening. What the doctor will often do in the mainstream is like give you this big dose of a hormone replacement that is way too much and then affecting you sort of even worse, right? And it's crazy what's going on, Natasha. Like Crystal was saying, she's a yogi, right? She loves to practice yoga. When menopause set in, suddenly her joints became stiff and less flexible. And she's like, what is going on? Well, that's just one of the side effects of this sort of reduction in some of these female hormones as you reach that point of life. So there are things that you can do, but you have to take it into your own hands and find those experts in that area that aren't just going to dismiss it.
Beautiful.
Thank you, Mark, because I was going to say that you need a full panel of your markers and of these hormones mainly, because if you analyze them in a, let's say, with a very careful way of looking at the different peaks of life that they are going to be being replaced, you will need to understand that you need certain amount of this replacement hormone therapy and not the amount that is being given in a drug, in a pharmaceutical drug.
Yeah.
Just
gentle,
like,
carefully monitored and titrated to your needs, right? And this is the secret. Yeah.
it's
And,
just like
and then realizing there are other things too, like your muscle mass will affect your hormone balance and the level of sleep that you have and the level of stress. So then it's more than just a hormone replacement therapy, even if it is bioidentical. Now it's a holistic approach.
Exactly. Yeah. Yeah, and thank you for bringing that up. I was just before this, I presented the five pillars that I talk about and how we are built on these five big areas of our lives. And if we just try to separate one of them, well, one of the others is going to go down. And we are always constantly in up and down situations, but we have to learn the message from each of those pillars and what is trying to give us as a cue so that we pay more attention, because sometimes it's in the emotional side, sometimes it's in the nutrition, sometimes it's just money problems. So it can
Yes.
be many things, no?
Yeah, well said. That's a really good illustration.
Yeah. Thank you, Mark. So finally, I think that we can wrap up this information in probably a simple message of the peptides. How could you help people understand that these molecules that are within us are the key to the future of our health, to understanding that they send plenty of messages and they are pretty much everywhere?
Yeah, well, I think we're just getting started on this journey, right? 100 years ago, insulin was discovered. They didn't even know it was a peptide hormone at that point. More recently, great awareness in this area of peptides. We are just beginning this journey. I kind of feel like we're in a mid place right now because we know how to synthesize these very easily, but maybe we'll start to understand that maybe, potency is not the full answer. I'm putting together a lot of science on this. Maybe if you go to our website, it's makewellness.com. Go to the science section. I hope to be adding more and more videos and science to the website there. There'll be some hints there, and just everyone should be continuing to learn. Like, don't ever stop learning, and learn as much as you can about it. I recommend this area because it is a potent area of health for the future. So just keep learning.
Yeah. Thank you, Mark.
My pleasure.
Thank you so much for sharing your knowledge and wisdom with us. And it's such an exciting journey you're on for the whole of humanity now and in the future.
Thank you. I'm pretty excited.
Thank you, Natasha, also. And thank you, everyone, for listening. So we hope that we get questions from you. And of course, any clarification, you can approach Mark in his website and where he just said, and we will put that in the description of this podcast. Thank you, everyone. Have a great day. Bye.
Bye-bye.